So today we're going to go back to the central angle notes. We're also going to be talking about inscribed angles. So central angles, this is an angle where the vertex is at the center of the circle. And then all of our central angles have to add up to 360 degrees. So I went over these different examples here. So when we're talking about arc AC, that was going to be 84 degrees, and then our arc of ADC, so we had to go all the way around, and we have to go in that same order of the letters. We just did 360 minus 84 to get 276. So we're going to look at different examples today. So on number 1, we want to find each angle or arc measure. So on number 1, we want to find the arc measure of JK. So the degree of the arc, remember, is going to be equal to the central angle. So when we're talking about JK, we're just going to say that this one is 21 degrees because they're going to be the same thing. Then we have the measure of angle JNM. So JNM, the angle is right here. So if this part is 21, remember that the semicircle is going to be equal to 180 degrees. So I can just do 180 minus 21, and I get that my answer is 159. All right, so then KL, so KL is going right here. So for KL, we can also look that we have another semicircle right here, and since this is 21, it's just going to be the same thing. This is 159, so we can kind of think of those as vertical angles. So then we want to find JKM. So I'm going to just erase some of these lines that I drew. So JKM, so we're going to go in that same order with our letters. So we start at J, and we're going to go all the way over to M. So if I start at J, I need to include this 21 degrees, this 159 degrees, and then this little measure right here is also going to be 21 degrees, since we had that semicircle right there. So if this was 159, then that one is also going to be 21 degrees. So all I'm going to do is I'm going to add 21, 159, and 21 to get my answer, which is going to be 201. And then the last one that we need to find on this one is the arc measure of MKL. So I'm going to go in that same order. So MKL. So I start at M, and I'm going to end up back at L. So what I could do is I can add 159, 21, and 159 because I'm going almost all the way around this entire circle. Or since I know that this little part is 21, I could just do 360 minus 21, and I can get my answer, which is going to be 339. So I'm going to do another example of these, and then this time you guys are going to answer some of them. So on number 2, I need to find the measure of angle UXV, so that's the angle right here. All right, so if we want to find that angle, that is going to be 72 degrees. So we can look and we can see that we have 72 for the arc measure here, which means that this angle is going to be 72. And then this little part here is going to be 21 because this is a semicircle. So I can do 180 minus 72 minus 87 to get 21. So then now I have another semicircle right here. Then we can also see and look that those are vertical angles. So this would also have to be 72. So then I went ahead and I already wrote in the measure of ST, so that's going to be 21. And then we need to find the measure of WV. So WV right here. So what will that be? All right, so that's going to be 108 because I can do 180 minus 72 right here to find that this is 108. And then I need to find TW. So TW. So if I start here at T, so here's T, and I need to end up at W. So I'm going to find the arc measure right here. So TW is going to be equal to what? All right, so I'm going to add 21 and 72, and I end up getting 93 for that one. All right, and then the last one that I want to find on this one is TVW. So I'm going to erase some of these lines. So TVW. So I start at T and I want to end up at W. So I'm going to go almost all the way around this circle. It's a very bad outline of the circle. But T, I have to hit V, so TVW. So since I found that TW right here, since that arc was 93, I can just do 360 minus 93, and I end up getting 267 for my answer. All right, so I'm going to skip down, and I'm going to do number 5 and 6. These are some examples with algebra. So on number 5, we want to find the value of, find the value or measure, or find each value or measure, yes, okay. So on this one, it gives us, we need to find x. So we know that this little arc right here is 26 degrees. So we know that we have a semicircle right here because this cuts through the diameter. So I can do 180 minus 26, and I can find that this arc is going to be equal to 154. So when I solve it, I'm just going to say 15x minus 26 equals 154. So I'm going to add 26 to both sides, and I get 15x equals 180. So now I would divide both sides by 15, and I find that x equals 12. So number 6, we're going to do the same thing. We need to solve for x. So here is my equation that has x in it. So for this one, I want to look and see. So I have 15 degrees here, and I have 103 degrees here. So I can see that this is a diameter. So we can see that these two angles right here are equal to each other, which means that EH, the arc EH and the arc FG are going to be congruent. So that means that this whole thing right here has to add up to 103. So what I can do is I can say 18x minus 2 plus 15 equals 103, or I could just do 103 minus 15, and I find that this arc is going to be 88. So I can say 18x minus 2 equals 88, and I can solve. So I add 2 to both sides, and I get 18x equals 90, and then I divide both sides by 18, and I get that x equals 5. All right, so on number 7, so number 7 would just be the same thing. The only thing that you're going to do is you would be plugging in the measures for each of those, and we will save that one to go over in class. So now we're going to skip down to, so we already had our arc length notes. Now we're going to skip down and talk about, we had sector notes. We're going to skip down and we're going to talk about inscribed angles and inscribed quadrilaterals. So when we're talking about inscribed angles, we're talking about an angle that has its vertex on the circle. And it has two sides that are chords. So our vertex is B, and then AB and BC are chords that are making up those sides. So an intercepted arc is the arc that lies between the endpoints of an inscribed angle. And then the degree of the inscribed angle is going to be equal to half of the measure of its intercepted arc. So our angle right here is going to be half of our arc. So our arc here is AC. So when we want to find the measure of angle ABC, we're just going to say 1/2 of our measure of our arc is our answer. So if our arc of AC was 50 degrees, then our angle would be 25 degrees because it's just half. So then when we have, when we're intercepting a diameter, then we are creating a right angle. So a right angle right here, because, so see how, we're cutting through the diameter right here. So if I know that this whole arc equals 180, if I divide that by 2, then that's going to be 90. So that means that the measure of my angle is going to be 90 degrees. So then when we have overlapping arcs, so if two inscribed angles intercept the same arc, then the angles are going to be congruent. So if we intercept the same arc, so this one tells us that the measure of angle ABD, so ABD, that's the angle we're talking about right here, and then this angle is going to be congruent to ACD because they both intercept this arc AD. So the measure of angle ABD is going to be congruent to the measure of angle ACD. All right, so we're going to do some examples of these. So on number 1, we're given the arc measure. And remember that our arc measure is basically going to be double what our inscribed angle is. So all I'm going to do is I'm going to take 62 and I'm just going to divide it by 2 to find my angle measure. So 62 divided by 2, I get 31 degrees. So that means that WXY is going to be 31 degrees. So if we're given the angle measure and we need to find the arc, so we're finding DGF, so we're finding this whole thing here. So DGF, all I'm going to do is I'm going to multiply 113 times 2, and I end up getting 226. So that one we kind of went backwards. So that one we're given the angle and we need to find the arc measure. All right, so number 3, we're looking for angle PQR. So remember when we intercept a diameter, that this is going to be equal to 180 degrees. If I divide that by 2, I'm going to get 90. So anytime that we have, so if an inscribed angle intercepts a diameter, then remember that it's going to be a right angle. So that means that this angle right here, PQR, is going to be 90 degrees. All right, so then we could have one like number 4. So it's asking us to find the arc measure of BC. So BC is right here. So we know that this whole thing, so this whole, I'm going to change the color, this whole thing has to equal 180 degrees. So if this part is 47, then our, we're just going to take that, we're going to multiply it by 2. So when we multiply it by 2, we get 94. So that means that this part of the arc, so arc AC, that means that that is 94 degrees. So I'm not looking for AC, I'm looking for BC. So BC, to find that, I'm just going to do 180 minus 94, and I get 86. So we just have to make sure that we're paying attention to what it's asking us for. So that one, we wanted the arc measure of BC. So now we want to find the measure of angle JKL on number 5. So JKL right here. So we're given this arc measure out here and this arc measure out here. So remember, all of the arc measures, they have to add up to 360. So what I can do is I can subtract these two from 360. So I can do 360 minus 53 minus 65. So when I do that, I end up getting 242. So that means that the arc measure for JML is 242. So now I have to take 242 and I'm just going to divide it by 2 to get my angle measure, which is going to be 121. All right, so now we're going to do a problem with algebra. So if I do number 7, I'm going to look at number 7. So on number 7, we need to solve it for x. So remember that our angle measure is going to be our angle measure is half of our arc measure. So if our arc measure equals 158, I can either divide this by 2 or I can multiply this by 2. So I can say 158 equals 2 times 8x minus 9. All right, so I'm going to just distribute. So I get 158 equals 16x minus 18. I'm going to add 18 to both sides, and I get 176 equals 16x. So now I would divide both sides by 16, and I get that x equals 11. All right, and then number 8, we're going to do the same thing. We're given the angle measure, and then I know that my arc measure is going to be double what my angle measure is. So for this one, I could just say 2 times 67, I know is going to equal 4x plus 58. So 2 times my angle is going to equal 4x plus 58. So I get 134 equals 4x plus 58. I subtract 58 from both sides, and I get 76. So I divide both sides by 4, and I get that x equals 19. And we are definitely going to do more examples of these in class. But now I want to talk about some inscribed quadrilaterals. So for these, so if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So remember that supplementary means that it equals 180 degrees. So that would mean when we're looking at our example here, so our opposite angles, that means that they are across from each other. That means that the measure of angle A plus the measure of angle C is going to equal 180. And then that also means that the measure of angle B plus the measure of angle D will also equal 180. So remember, our opposite angles are going to be supplementary. So we can look at a couple examples with these. So on the first one, it wants us to find J. So J, its opposite angle, is going to be L right here. And then K, its opposite angle, is going to be M. So for J, I'm going to do 180 minus 92, and I get 88. And then for K, my opposite angle is 45, so I would do 180 minus 45, which is going to be equal to 135. All right, so on number 2, it gives us a little bit different information. So for number 2, it gives us the arc measure that is across from S. So we are basing S off of this arc measure here. Hang on. Let me back up. So first we're going to find R. So if we look at R, we actually can't find S. I lied. So we're going to look at R. So our intercepted arc for angle R. So we're looking at this angle. So we have Q, P, and S. So if I add those together, and then I divide by 2, so I have 126 plus 90. If I add them together, I end up getting, or add them together and then divide by 2, because remember, our angle is going to be half of the intercepted arc. So I add them together and then I divide by 2, and I get 108. So now I can find my other 2 angles. So angle P is going to be equal to what? Angle P is going to be equal to 72. So then across from Q, I have S. So I'm just going to do 180 minus 93, and I end up getting 87. So we will definitely do more of these in class, and we will go over how to solve some with algebras in class, solve with algebra in class as well.